After using this CNC machine to level the table and play around with it, I realized that this motor for the Y is underrated big time. It works, but it is very restrictive and you can't go that fast, and it takes forever to print a job. So this is an 80 ounce motor. We're going to switch it out with something else. Let me explain more. As mentioned in the intro, I'm going to be changing the motor on the Y-axis, and currently it has an 80 ounce motor, and we're stepping that up to a 305 ounce motor that has more amperage, more power and speed. And the reason why we're doing this is so we can travel faster and we can cut harder materials at a quicker, more efficient speed. So let's go ahead and click on our config button in Mach3, and we're going to look at the motor tuning section. Now, others have asked in the past how to tune the motors, so because I'm changing this motor out, I'm going to go through the setup procedure of how I optimize my motors for Mach3. Once you do this, you don't need to touch it again until if you make changes, physical changes. So we're going to go through this. Now, I'm here at the motor tuning and setup page on Mach3, and you can see that there's this graph, this visual representation of your motors, and currently we're looking at the X-axis, and you can switch to the different ones by clicking these buttons here, X, Y, and Z. Now, there's three numbers that you have to be concerned with when you're tuning a motor. The first is called steps per unit, and you can see mine set for 8,005. We'll go over what that means in just a moment. The second one is the velocity, and that is how fast per minute you can go. Now, my units are set for inches, so I can travel 35.418 inches per minute max. That's as fast as that motor will go on my X. Now, I should be at my Y because that's the one we're going to be changing. You can see my Y, I can only go 26.796 inches per minute, and that's due to the fact there's a lot more load on that motor and it's working harder than the X, and that's one of the reasons why I have to change it. I can't get enough speed out of it that I want. So again, the first number here, or the second rather, is velocity. I can go 26 inches per minute. If you're set for the metrics, it's millimeters per minute. The third number is acceleration, and that is how fast you can ramp up and down. And just like a car, when you step on the gas and try to go 100 miles an hour, there's a time that it takes to reach full acceleration, and then when you let off the gas, you also have to come down in acceleration. And that's what's represented here is the acceleration. It ramps up, and then it's at 100% of what the motor can do, and then when you ramp down, that's how long it takes to stop, basically. And you can adjust these sliders. Let's move the velocity. You can see that I can change the representation that way, and the acceleration will change the visual this way. So we're going to discuss how to find these numbers the way that I do it anyway. Now, going back to this first number, the steps per, the 8,005, let's cancel this for just a moment. I'm going to go into the settings tab, Alt 6. You can see that there's a button here right by the reset button. It says steps per unit. And if you click on that, it gives you the opportunity to calibrate your axis, and this will determine what your number is on your steps per on my 8,005. Now, this varies depending on what kind of screws you have, what kind of motors you have, what kind of drivetrain. Do you have a direct drive train? Do you have belts? Do you have pulleys? what the ratios are. So your number is going to be different than mine. But what it basically amounts to is how many times does the motor have to turn to reach 1 inch. And in my case, it has to spin 1,005 times to travel 1 inch. And again, I'm not going to do that because that number is already determined for me. But I wanted to show you how you get that number. So now that we've talked about that, let's go back to our config motor tuning and click on our Y. Now, when you figure these out, it's a good idea to write them on paper. Your steps per, which is 8,005, my velocity is 26 inches a minute, and my acceleration is 1.78. And I recommend that you do it for all of them, X, Y, and the Z. So we're going to go ahead and change that motor out, and then we'll have to reset up our Y to accommodate the new setup, the new hardware. Generally, once you set this up, you don't have to touch it again unless there's a problem. If you're losing steps and your machine's not accurately moving the bit to the measurement that you expected, perhaps you're going too fast and you're losing steps. And this is where you would adjust it. Here is in the movement profile. If I try to go too fast, if I have my number set up to go too fast, the motor is not going to catch up to the commands, and it's going to be too quick for it, and I'm going to get wrong measurements basically. So anyway, now that I've described that, I've showed you the numbers, we're going to go ahead and switch out the motor physically, and then we're going to come back to this screen and we're going to set that motor up. Now this is not scientific. I'm just going to go ahead and move the Y around so you can see how quick it is visually, to give you an idea of the speed difference after I change that motor. So let me go ahead and just jog it for you. Here we go. That is the max that I can travel currently, and that would be the 26 inches a minute. That's what it looks like. If you notice my X, it's moving quite a bit faster, and that's because I do have it set up to go faster in the profile of the tuning, because the X is not carrying as much weight. There's 3 motors on this machine and they're all the same. They're all 80 ounce, but we're going to be switching the Y out with this one, and this is the 305 ounce motor that I talked about, and this is from Hobby CNC, and this is 4.2 volts at 3 amps. So we'll also have to adjust our trimming pots in our controller to give this motor more current, as well as to make adjustments in Mach 3. So anyway, on with the motor switch out. So this is the Y-axis motor here, the 80 ounce motor, and I wanted to show you the size difference of the 305 ounce. So it's quite a bit bigger, not a whole lot, but the ratings are certainly bigger. So you can see I've got to remove four bolts, and I have to remove all the wiring harnesses, disconnect it from these connectors, and switch it out. So we'll do that now. Now I have to get under there and release that collar for my coupler. The way I've got mine set up, the lead screw goes all the way through. So if I remove this bearing block, I can pull the motor out that way and then remove the coupler. So here you can see the bearing, and I've got two nuts that are jammed into each other to prevent that from turning. And the back of this is routed out to accept the bearing. So if I remove these two nuts, I can remove the bearing, and then I can slide the shaft through. And there we have it. There is the old motor. This is an 80 ounce 1.8 degree stepper motor, KP56LM2-97. Pretty good motor though, considering it moved this large machine for such a small motor. Looks a lot bigger, doesn't it? Luckily I have just enough wire I should be able to make over here. Yep. Wish they'd put longer wire on these. Jeez, chintzies. Here's the documentation for the motor. This is the Hobby CNC 305, and it shows me all my various colors and where they go. So simple. Just put them on those connections. Now we're going to have to get in our controller and change our voltage reference for the Y, because we're putting in a bigger motor and it takes more voltage. We can leave it as it is, but it'll be defeating our purpose, because it won't be any stronger unless we give it the voltage that it needs. So I'm just getting the cover off this now so we can adjust that. And before we can adjust our voltages, our reference voltage, we have to disconnect the stepper motor. And that's easy to do thanks to these connectors we put on. Now before we can set our voltage reference, we have to put this jumper back on. J4, which is our idle current reduction, so it doesn't go into that mode. So jumper on until we get that set for the Y. We can look on our documentation that came with our board, and we can see that for a 3 amp motor we want to set our voltage reference to 0.42 volts DC. So let's put our multimeter on that and set that up. Okay, we've got our meter grounded and set on DC voltage. The pad is right down there for the Y, and here's the trimming pot. Need a little screwdriver. Let me grab that. Okay, I've got my little screwdriver, and again, the number that I'm looking for is here, 0.42 volts. So let's go ahead and touch that pad. We got 0.17, and we're going to 42. Let's turn the screw. There we are. I'm actually going to go just 1 point less, so 0.41 for the Y. Okay, we got our button back up and it's ready to be turned on. Let's go up top and get started. Okay, I'm going to click it on. And let's go ahead and move the Y. So it's pretty much moving the same speed that it was, because our settings are still for the old setup. So Let's go ahead and go into the settings and we'll begin to optimize this motor for the Y. Well, the first thing I'm going to do is go back into configuration and go to motor tuning. And I'm going to click on the Y because that's the one that we're working on. And our old settings are still in there. Now I have not changed the gear ratio or the type of motor. It's still a 1.8 degree motor. So this steps per will remain the same. The only two numbers that I have to work on are the velocity and the acceleration. So once you select your axis, the one that you're going to be working on, you use the up and down arrow key to move the motor. And those are the two keys. The up and down key are the ones that you'll be using to do the testing. Now this might not be the absolute best way, but it's my way of doing this. What I like to do is move the acceleration down quite a bit. And I'm going to just push this down like this and use my keys. Here you can hear the motor revving up. Let's go some more. Now you can really hear it. Let's go some more even. So you can really hear it accelerating and decelerating. So what I like to do is get a happy medium where it's got plenty of room to get started and stop. A little more. Whoops. See how that sounds. And I do go by sound a lot. This is a little bit too much right now. It might be good for a setting in the future, but for now we're going to take it down some. Right in here. Yeah, a little less. What I'm listening for is just a little bit of a ramp up and ramp down. Can you hear it? Let's go just a tiny bit more. And you can also change the numbers here if you want to. But I like using the sliders for my coarse adjustments. So now that I've got my acceleration down to a more than reasonable rate, I start playing with the velocity. And what I'll do is I'll move the velocity until the motors start to stall or miss steps. So I'm going to take it up quite a bit here. Let's test it. Hear that slipping? Let me give you a shot of the actual machine as I'm doing that. So the motor is actually slipping, and that means that I'm going too much. Let's go back to the screen now. So I know that's way too much for my velocity, and that's at 65. Let's bring that down a little bit. Test it again. Still too much. You can hear it. Still too much. Getting better. Let's come down some more. That's around 40 for the velocity. It's 40.84 right now. So what you do basically is you set your velocity generously, so you're ramping up and ramping down quite a bit. You can see quite a slope on there, so it's not so sharp. And then you move your acceleration down till it's comfortable. Now I can start typing in numbers. Let's see if we can go higher. Let's change this to 45. Okay, so my velocity is now at 45. Let's listen to that. And you can tell that it's now again slipping. So 45 is too much and 40 seems to move. Let's try 43. Alright, let's see what it does. It can handle 43. Oh, it slipped again. So I'm going to say probably 40 is the max. Let's try that again on 40. Listen to it. So you know, 45 it slips and 40 it does not. Now I don't want this thing to lose any steps in the future, so what I'll do is be generous and give a little bit of that back. So I'm going to set this to around 38. Let's listen to it again. And of course I want to move my table the full length back and forth, and I'll do that, but I'm just trying to give you a taste of what I'm trying to do here. Now that I've got that set to 38, I'm pretty comfortable with that as my velocity. So now I can start playing with my acceleration again. So I'm going to go back to my acceleration and I'm going to see if I can bump it up a little bit more. Let's take it all the way here. So it can pretty much handle as much as I can throw at it, but I'm going to back it down just a little. So there you have it. My velocity is right around 38, my acceleration is around 23. Let's go back to this velocity and see if I can jack it back up to 40 and how it will react. I can do 40, but anything past that is see. It just can't handle it. So I'm gonna go 39. So I think that's good for now. I'm gonna go ahead and save those settings, and I'm gonna run a job in the air and see how it performs and make sure it's not missing steps. So let's recap what I've done. I've taken, you start out and move the velocity way down so that there's plenty of ramp time to start and stop. And then you move your acceleration to a point where you're stalling out and then go down from there until you feel comfortable. So if it's stalling out around 40 or 38, you're going to want to jack it down to like 35 to give yourself some headroom. Once you've established the velocity, in my case it's 39, then you can start to move your acceleration back up and see if you're still stalling, and that's my technique, and it seems to work well. So I'm back in the run mode. Let's go ahead and jog. That bigger motor is quite a bit noisier, isn't it? So let's recap the difference in performance that we're getting. Let me go back to that config motor tuning on the Y. So on the Y, I was doing 26 for my velocity. So I was running at 26, 27 inches a minute. And now with the new motor, I'll be doing 39 inches a minute, which is quite a big difference. It's 1/3 faster. And then the acceleration is 23, and on the old motor it was 1.78, so that's also quite an improvement. It's a much steeper, it's quicker to get to 100%, in other words. So that's it in a nutshell. Yeah, let's go out for some final thoughts on changing out motors and how to tune them. So I hope you got some use out of this video. In a nutshell, what we did is we went ahead and switched out our motors, and don't forget to go to your controller and set the reference to the right amperage for your motor. Otherwise, you'll still be using your old voltage and you won't see an increase in a new motor. After that, you go into Mach 3 and you play with your velocity and your acceleration. The first thing that we did is we moved our acceleration down to a number that gave us a very large slope, so we could start and stop very slowly. And then after we did that, we played around with the velocity and we did it until the motors stalled out, and then we backed it back down and gave it some headroom, and then we went back to the acceleration and we moved that as quickly as we could without affecting the steps or any more stalling. At that point, we went ahead and saved our settings, and we're going to go ahead and test it before cutting. We'll do some air cuts on the Roadrunner, and that's it. So I hope you got some use out of this video about changing out motors and how to set up the Mach 3. Thanks for watching. We'll see you on the next one. Don't forget to give us one of these. Bye for now.